Good morning, Titans, and hopefully your quiz went well and now you're ready to tackle a new concept. But before we tackle a new concept, I just want to review distributing. And so we're going to have you multiply the following. And I'll do number one, and then I want you to do number two. So you may want to pause so you can do that. And I'll show you the answers. So for first, number one, just using the distributive property here, we're going to take 4 times x squared, which would be 4x squared. Then we're going to take 4 times the 5, and there's a minus sign, so it's minus 20. Alright? So now, pause the video just for a moment and do number 2. Alright, so now, we look at the answer for number 2, we distribute 2x times x squared would be 2x to the third, and 2x times negative 9x would be a negative 18x squared. Remember, when we're multiplying, we have to add the exponents of like bases. So number 3, I'll go ahead and do again. So we distribute through 2x squared times x would be 2x to the third. Then 2x squared times a negative 65x to the third would be a negative 130 x to the fifth. Alright. Now, this might be a good time to pause. Try to do number 4 on your own and put that in your notes, and then I'll reveal the answer. Alright, so here we go. 2x squared times xy would be 2x to the third y minus 8x squared y plus 6 x squared times x would be x to the third, then y squared. Alright, and that's just a review of multiplying using the distributive property. You're going to see how that will come into play in our new concept. So 9.5 common factors. So the first thing we want to look at is what's the greatest common factor? And the greatest common factor is the largest number that divides exactly into 2 or more numbers. So if we look at this, and this is a concept that you've done before, and so 6 and 15, what's the greatest common factor of 6 and 15? Sometimes you can just look at the two numbers and know what it is, but sometimes you might have to do with a factor tree. So 6 breaks down into 2 times 3. 15 breaks down into 3 times 5. So then I write it, 6 is 2 times 3. And 15 is 3 times 5, and the common factor is 3. So the GCF in this problem is 3. So in the next ones, we have 3 numbers. I do the factor trees. Well, 16 is 4 times 4, which is then 2 times 2, and this is 2 times 2. So then 16 is 2 times 2 times 2 times 2. Then we have 24. Well, that's 3 times 8, and that's 4 times 2, and that's 2 times 2. So then 24 is 2 times 2 times 2 times 3. Now we have 60. So 60 is 3 times 20, 2 times 10, and 2 times 5. So then 60 is 2 times 2 times 3 times 5. Well, now we have to look at what's common. Well, there's a set of 2's that's common in all 3 numbers. There's another set of 2 that's common in all 3 numbers. And that's it. The 3's aren't common in all 3 numbers. 5 isn't common in all 3 numbers. So the product of 2 times 2 is 4. So 4 is my GCF. Now sometimes you might just look at these and you think, okay, what's common in all 3 of those? Well, 3, 6, 14, and 28, they don't have a common factor because 3 does not go into 14. 3 does not go into 28. So in number 3, there is no GCF. Now, if we're looking at common factors when we're dealing with variables, all right, when finding the GCF of variables, it must first be common in every term. Then you take the greatest number of times it is common, which will be the lowest exponent of the variable. So here we have to find two things. We have to find first the numerical common factor. So of 4, 6, and 10, 2 is the numerical common factor. And then x to the third, x squared, and x. Well, x happens in all three. And x to the third is x times x times x. X squared is x times x, and then just x. Well, x is common only one time. So my GCF is 2x. If we look at the next one, if I look at 9, 12, and 15, the GCF is 3, because that's the largest number that divides into 9, 12, and 15 evenly. And then, if you notice, if I would write these all out as y, 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 and y, and then y, 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 and y, y, y occurs twice in all three terms, which is also the lowest exponent. So the GCF is 3y squared. So this last one, again, you may want to think about what it would be on your own. Pause it. All right. Now, of 18, 12, and 6, 6 is the GCF because 6 divides into 18, 6 divides into 12, and 6 divides into 6. And then m is common in every term. But the lowest exponent of that is m squared, which is the greatest number of times it is common. So the GCF is 6m squared. Well, now, this takes us into factoring. Factoring is the process of writing a sum as a product. Or in other words, it's finding what to multiply together to get an expression. So here is the expression. And we need to think about how we can write it as a product of two factors. Well, if you think about when we were multiplying using the distributive property, our answers are now going to look like that. So I look at the two terms, and 3 is a common factor. And so I have to divide both terms by 3, and whatever's left is what's going to go on the inside. Well, 3x divided by 3 is x, and 12 divided by 3 is 4. So then my answer is this. This is now in factored form. I have 3 times this binomial. And now that's written as a product. This was a sum, because it's a sum of two terms. Now it's a product. So, here we look at some more examples. Number 1. The GCF of the numbers of 4 and 16 is 4. The GCF of the variables is y to the third, because y is common in both terms. Now, I have to decide, what do I have to multiply by 4y to the third to make it equal 4y to the third? Well, that'd just be 1. What times 4y to the third equals 16y to the fourth is 4y. Now again, the other way to think about it is if we were to divide that GCF of 4y to the third out of each term. Here the 4's would divide out, the y to the thirds divide out to equal my 1. 16 divided by 4 is 4, and if I subtract those exponents, I'd have 1y left. And number 2, I first look at the numbers of 6, 15, and 9, and 3 is my GCF of the numbers. P happens in all three terms, and the lowest times it occurs is once. So, now I have to decide what times 3p would equal 6p. Well, 2. Now, what times 3p would equal 15p squared? Well, 3 times 5 is 15. P times p is p squared. And then what times 3 gives me 9 is 3. And what times p gives me p to the third would be p to the second. And again, if we were to divide each of these terms by that GCF on the outside, we'd end up with that same answer. If we look at number 3, 8 and 17 don't have a common factor, and the variables are different. So these don't have a common factor in either term. So we call this a prime polynomial. And then number 4, We look at the GCF. Well, 2 is common in 4, 6, and 8. I see that x occurs in every term, and the lowest exponent of x is 1. Y occurs in every term, and the lowest exponent of that is y. So there's my GCF. That's what goes on the outside. Now, what times 2xy would equal 4x squared y? Well, I need a 2 and I need an x. What times 2xy would equal 6xy? A 3. And what times 2xy would equal 8xy squared? Well, 2 times 4 would equal 8, and I need one more y. And now that's in factored form. All right? And that concludes the teaching of GCF for today. And so you're now going to go ahead and do some practice problems on whiteboards with the sub, and then you'll have a video to watch tonight over the second part of 9.5.
Made with Doodlecast Pro.